But today we're going to focus on how to simplify, multiply, and divide rational exponents. We're going to look at about 10 examples. And if you guys have any questions, please let us know. Remember, we live stream every Tuesday and Wednesday, 6:30 p.m. Eastern Time. So when we're touching on this topic, the basics is just understanding what exactly does this mean. And we should already know with rational exponents, anything to the 1/2 power is just equal to the square root of that number. That's all we're asking. So if we take 8 to the 1/3, right, all we're asking for is the cube root. And we should know that the cube root of 8 is just 2. Now, when we get over into the more complicated fractions, meaning it's not to the 1/2 power 1/3, this is an easy way I like to break it down to students. We could split it. So we could go in and say, okay, what is the square root of 25? Or what is 25 to the 1/2 power? Then when we figure out that answer, we could then take that answer and take it to the 3rd power. So if I was trying to solve this problem using the properties of rational exponents, right, this would turn into 5 because that's the square root of 25. And then when we apply this outside exponent to the 3rd power, we should know our answer is just going to be 125, right? So when we go into our next example, let's look at something like this. So they may give us 32 to the 4/5 power. So if we apply this same rule that I just did with 25 to the 3/2, we could take 32, figure out what is its 5th root, right? So we take it to the 1/5 power, and then after that, we could raise it to the 4th. So what does this mean? It means what number can I take and multiply it by itself to give me 32? And once we simplify this, we should know that that answer is 2, right? 2 to the 5th power gives us 32. So when I simplify this, the 5th root of 32 is 2. I bring that outside exponent down. And now when I take 2 to the 4th power, my answer should be 16. So this is what we mean when we say properties of rational exponents and how to break down. So let's say you had something like this, right? We have 8 to the 2/3 power. So these are the two ways we could solve. The first method is what we've been doing, right? So I'm going to take 8. I'm going to figure out what is its cube root, right? That's the 1/3. And then I'm going to take that and square it. So we already know from this first example, the cube root of 8 is 2. Once we bring down that outside exponent, 2 squared is going to give me 4. Now, real quick, let's erase and get some space right here. All right, we can erase this. Let's say we did it the other way, and you can do it this way, but sometimes it's a little bit more complicated. So let's say we did 8 squared, and then we found, or we took the 3rd root of that. So we're doing the same exact thing, but we're doing it backwards. So instead of finding the cube root, then squaring it, we're going to square this and then find its cube root. So what this turns into is 64, right? Because that's 8 times 8. And then with 64, I find the cube root of 64. And we should know just by practice repetition that the answer is 4, right? We're going to get the same exact answer. 4 times 4 is 16, times 4 again is going to give me that 64. Properties of regular exponents still apply. So what happens is that we're going to turn that into a fraction. We're going to take the reciprocal. So we're going to have 1/16 to the positive 5/2. I sometimes see students believe or think that they got to take the reciprocal of this fraction, the exponent fraction. That's not necessarily correct. Now that we understand that, right, let me just go down. We're going to do this now and simplify. So we have 1/16 to the 1/2 power, and we're going to raise that to the 5th. So we know 16 to the 1/2, All right, that's going to give us 1 over 4. That's its square root. And when we take 4 to the 5th power, let's see what we get. All right, so we're going to get 1 over 1024. So if we were to solve this problem right here, the answer will be 1 over 1024. So this is if we have a negative exponent, we're still going to use that exponent rule. Now let's say they gave us something where we have an exponent that is a decimal. How would we solve this? I got you. We move the decimal over, right? 2 places to the left. This is all over 100. So what we're trying to do right now is simplify this fraction to lowest terms. We're talking about 250 over 100. So off rip, divide by 10, we're left with 25 over 10. Now I'm going to divide both top and bottom by 5. So I'm going to get 5 over 2, right? Double check. Yeah, we're good. So what we're saying is 4 to the 2.5 power as a decimal is the same thing as 4 to the 5 over 2 power. So now with this step, it's a lot easier and simple for us to break down. So if we want to break this down, we're going to do 4 to the 1/2 power. And once we figure that out, we're going to raise it to the 5th power. So this turns into 2 to the 5th power. And if I'm not mistaken, I think that's 32. Yep, this is going to be 32 as a final answer. So if you have an exponent that is a decimal, you got to take that decimal, convert it into a fraction in lowest terms, then we're able to use rational exponents to simplify. So when we're multiplying radicals, we know the index has to be the same. So this has an index of 2, this has an index of 5, meaning we cannot multiply. But if we convert the form from radical to exponential, meaning, right, we have, this is our base, power, root. So if we switch it over to the fraction, we may be able to do something. And this is why this is important for us, how to go from radical form to exponential form and exponential form to radical form. So this turns into 5 to the 1/2 power. And then I'm going to multiply this by 5 to the 1/5 power. So now that we have the same base, we are able to multiply and combine those exponents. However, fraction rules apply, meaning we have to have the same denominator. I know the lowest common denominator is 10, so I'm going to multiply top and bottom by 5 right here, and this top and bottom by 2. So I get 5 to the 5 over 10 power multiplied by 5 to the 2 over 10 power. And now once I simplify by adding exponents, I get 5 to the 7 over 10 power. And please be mindful, you may not see it written like this. They may convert it to radical form, meaning it's going to look something like this as a final answer. So please just be mindful. If you don't see this answer in exponential form, know how to convert it to radical form. The second example, what they like to do or like to test us on is something like this. 16 to the 1/3 multiplied by 4 to the 1/3. So remember, with these rational exponents, we have to have that same base. And right now we don't, but we could get it. Remember that 4 squared is equivalent, meaning it has the same meaning as 16. So 4 to the 1/3 stays the same. 16 is going to change into 4 squared, and that exponent stays the same. Now, before we could actually multiply or add these exponents, we have to simplify this power of a power rule, meaning I'm going to multiply 2 times 1/3. So now this turns into 4 to the 2 over 3 power multiplied by 4 to the 1/3 power. So now, same base, same denominator, I'm now able to add my exponents. So I'm going to get 4 to the 3 over 3 power. Remember, it's a fraction. So 3 over 3 simplifies to 4 to the 1 power, and we should know that anything to the power of 1 is just itself. So our final answer for this would be 4. So I want to tell you all, we could just multiply it straight across, then simplify, because they do have the same roots, right? We could do that. But let's just say for the purpose of this video, we wanted to practice on rational exponents. So we already know 5 to the 1/4 power multiplied by 125 to the 1/4. Now, similar to this problem, we do not have the same base, but we're able to combine and get the same base. So 5 to the 1/4 stays the same. 125 I could express as 5 to the 3rd power. So this turns into 5 to the 3rd power, and I'm going to raise that to the 1/4 power, right? So we have 5 to the 1/4 multiplied by 5 to the 3/4. Let's double check that we're good right there. Yep, that's absolutely correct. So luckily for us, similar to this one, we didn't have to come up with equivalent fractions because they already had the same denominator. So once I add, I'm going to get 5 to the 4/4 power, which similar to this, reduces to 5 to the 1st power, which is just 5. So this is what we mean when we say multiplying rational exponents. And I have one more example before we go over to the division. Please understand that this is a trick question. This is what I mean. We can't rewrite 21 so that it has a base of 7, right? There's not really a way for us to do that. However, if you notice, that fraction is the same. So if we go from exponential form to radical form, we could probably do this, right? Because this is saying what? Radical 7 multiplied by radical 21. And remember, we have the same roots. So we're able to multiply those two radicals together, then simplify. So when I multiply 7 times 21, this is going to give me radical 147, right? And then because I know from practice, I believe 49 is the largest perfect square. That does go into this. So now when we simplify, this is 49 times 3. Perfect square comes out, and our final answer would be 7 radical 3. So first off, we know that when we're dealing with properties of exponents in a fraction, we subtract the exponents. But right now, we're dealing with radicals. So let's just convert it, right? So this is x to the 1/2. If we don't see a number in this root, we always assume that it's 2. Down here, right, this is divided by x to the 2/3 power. Sometimes students will come in and put 3/2 because they're trying to get the same denominator. Just make sure you convert correctly, because that is a very common mistake. So I'm going to rewrite this now, right? Let's see. So I'm going to write it like this. And this is just optional because it just helps me to see this a little better. So right now, lowest common denominator is probably going to be 6, right? So we're going to multiply top and bottom by 3 for 1/2. So we get x to the 3/6 divided by, and in this fraction, I'm going to multiply top and bottom by 2 to get the same denominator. So x to the 4/6. Now that we have the same denominator, now let's just put it back in the fraction. So x to the 3/6 divided by x to the 4/6. So we know we're subtracting. So when we continue, we have x to the 3/6 minus 4/6. So once we simplify this now, right here, we're going down under, we're going to get x to the negative 1/6. You guys agree, right? Yeah, I think this is the correct answer, yeah. So remember, negative exponent rules, right? We're not going to have this negative exponent. So now that it's a fraction and I flip it, this turns into 1 over x to the positive 1/6. I may see it expressed like this, but just remember, if it's in radical form, meaning we take one more step, this will be 1 over the 6th root of x. So just please be mindful of both of these answer choices, because these are equivalent. They're the same thing. One's just written in exponential form, the other's in radical form. So same exact process, right? If one was a variable, now we have an actual number. So we have 6 to the 1/2 all over 36 to the 1/3. So we already know bases are not the same, but we could rewrite 36. So now we have 6 to the 1/2 all over 6 squared to the 1/3 power. Now I take this one step further. Let's go right here. I'm trying to keep it more neater for you guys. So 6 to the 1/2 all over 6 to the 2/3. So now we're back at the part where what? We need equivalent fractions. So I already know denominator is going to be 6. Let's multiply top and bottom by 3 for the first fraction. And then let's multiply top and bottom by 2 for the second fraction. So what we have now is 6 to the 3/6 divided by 6 to the 4/6. And let's just double check to make sure. Yep, we're good. All right. So now when I subtract, right? So let's write this out. We're going to get a very similar answer where it's 6 to the -1/6 power. So again, we have to express it as what? Reciprocal, right? Because we can't have the negative fraction. So 1/6 to the 1/6 power, remember that is exponential form. If we do it in radical form, okay, good. Make sure we're on track. We have 1/6 root of 6. So just please make sure, family, that you understand how to do both of these or switch from one form to the other. First way, we're going to go the easier route. So we have radical 3 times radical 12. This is what this is basically saying, right? We know this, we could break down. So we have radical 3 times radical 4 times 3. When we simplify, this turns into 2 radical 3. Rewrite the first radical. Now when I multiply, the only thing I'm multiplying is radical 3 and radical 3. So my answer turns into 2 radical 9. And when we simplify this, right, it's a perfect square, this turns into 2 times 3, which equals 6. Now I know you guys are saying, Peters, we're talking about rational exponents. Why are you showing us that? Because I need you to see the easier version so that you understand the harder version, okay? And let's just switch to blue just to make sure that we're on the same track. All right, so this stays the same, right? 3 to the 1/2 multiplied by what? So remember, the form's going to look different. It's going to be 4 times 3 to the 1/2. Now at this step, I'm going to apply this exponent to both of these. So I have 3 to the 1/2 times 4 to the 1/2 times 3 to the 1/2 again. So now guess what happens? Right? We're going to have 3 to the 1/2 times 2 times 3 to the 1/2. So family, remember, in this format, I only could multiply like bases. Okay, so now let's just take this right here. So we're right here, 3 to the 1/2 times 3 to the 1/2 times 2. I just moved it around so that we could see when we add, this is what happens. We add the exponent, so 1 plus 1 gives us 3 to the 2/2 power times 2. So now I simplify this, right? This is just 1, and we know anything to the first power is just itself. So it stays 3, bring down the 2 and multiply, and now we get 6 as the final answer. I'm sorry, just like when it comes together so well, family. But man, family, we are done for today's live stream. Please comment down below, smash the like button. Let us know if we need to double down with another video on this topic.